Hi, everyone. Thank you for coming today. It means a lot for you to be here. As Yoga said, my name is John Rex, and this is my 909 capstone presentation. My project deals with creating a hostility index in Pima County in the Sonoran Desert. My goal when setting out for this project was to create and develop a web map or an application that can be used to help in the location of missing people and for search and rescue operations. Quick note before I get started, I would like to point out that the subject matter of my topic is very heavy. And so I would invite everyone here to sit with the discomfort that it may cause, because this has been a long time human rights issue that has been going on since the late 80s and possibly even before. And there's been a lot of scholarship done on this topic, and it can be difficult to talk about. And it was difficult for me to research in some ways, because what we're looking at is an ongoing social and political trauma. So with that being said, I'll give you an overview of my presentation. I'll start by introducing the study area and giving you some background on my topic. Then I'll go over my flow chart, which is an illustration of the geoprocesses that I used in ArcGIS Pro. Then I'll go over the terrain layers. These will be in my regression section. These will be referred to as independent variables, but for the purposes of the GIS analysis, they are individual maps that I created using different tools in ArcPro. Finally, the culmination of these was to run the data variables in a regression software that provided me analysis results, which I will go over, as well as my hostility index, which is also known as a binary model in ArcGIS Pro, and that was my final product. And at the end, I'll say some closing thoughts and open the floor for discussion or questions if anybody would like to ask any. So what we have is a migration system in crisis. The reality of people living along the Sonoran Mexican border is not clearly and honestly represented in how policy has been created. Also, the policy that is currently in place is left over from over 30 years ago, at least, and does not currently meet the realities of, or the political and social realities of the people who are most affected by the policy. So this policy that I'm referring to is one called Prevention Through Deterrence. It was enacted in 1994 and signed into law by President Bill Clinton, formed under the fallacious belief that deterrent strategies in general will deter illegal migration. This has been noted and proven to be false, as people will still try and do it because the political realities that they are trying to escape from are so bad that it is worth the risk of bodily and physical harm to make the journey. Therefore, it does not actually do anything to deter people from coming. Rather, it turns what would otherwise be a beautiful stretch of pristine desert into an open grave. So I am standing on the shoulders of giants, so to speak, to use that phrase. And a lot of my work, all of my work, would not be made possible without the people who have come before me, Particularly, I am indebted to the work of Humane Borders and the Pima County Office of the Medical Examiner. They have created, through a GIS partnership, a series of queryable web apps known as death maps. And these give information about every person who has been recovered within Pima County, particularly along the Sonoran Desert, or within the Sonoran Desert. So they are looking to raise awareness about this and use it as a way to shed light on this issue by creating a virtual memorial of sorts that recognizes the shared humanity of the people who have died and trying to come into this country. So what I'm looking to do, or what I set out to do, was to draw correlations between where bodies have been recovered and the terrain. So each terrain, if you're not familiar, a lot of my layers come from raster images, which are satellite data, and each of these images hold data values within each pixel cell. And this is a numerical value to symbolize some quantifiable element of the terrain. So I used the 30-meter DEM and transformed it using these tools you can see on the screen: focal statistics, aspect, slope, and Euclidean distance. The output rasters from these were then sampled using the sample tool within ArcGIS Pro, along with the Humane Borders data and the random sample data, which I created. The purpose of the random sample data, which I will touch on a little bit later on when I go into the logistical regression, is that in order to run a binary logistical regression, you need a 0 and a 1 group. 1 symbolizing your study group and 0 symbolizing nothing, or the null hypothesis, the absence of a phenomenon. So after taking all of these different data layers, I created an output class, or output table, which I exported to an Excel sheet, excuse me, which I exported into an Excel sheet, which was then used within the SPSS statistical software to run my binary regression. What is not shown here is that I took the data from the, that I received, the statistical information from the regression, and put it back into ArcGIS Pro, which I then calculated using a raster calculator, which looks at the terrain values, or the sampled values from each of the terrain layers, multiplied by the coefficient to create a layered image, or a binary model, which will show where the statistical software believed to be the most dangerous areas of the Pima County Desert, based on the data that was provided. So first up, we have my DEM, which is what I touched on earlier, and this is the foundational layer used for representing terrain data. This one happens to be 30 meters. Up next, I have aspect. This was a transformational layer that I used to determine direction, or magnetic direction. So 180 degrees is due south and 0 degrees is north. Slope is a measurement of steepness, or the grade of the terrain, and this a higher number indicates a steeper or more severe slope. Shelter is based on a virtual cylinder being placed on the surface of the DEM. Higher levels of shelter indicate that there's more exposure to the elements of the sun. In this case, what we're looking at, we see this pretty much everywhere along the border region, it has relatively high exposure. The next measurement is roughness, which is a simple measure of how coarse or difficult it is for people to walk over the terrain on foot. Again, higher number indicates more difficult terrain. This was a raster layer that was used to calculate the distance from where the bodies were recovered to the nearest roads, major roads. This looks at the pixel value and says the value that's closest to the neighboring cell will create a closer proximity, and this is symbolized by a darker color being further away from the road. Same idea, but with stream beds. If you're from Arizona, you know that most of them are dry except during the monsoon season. And so same operation, but different feature. Finally, I have 30-year temperature averages, which look at years from 91 to 2020. So what is a logistical regression exactly? It is an analysis to determine the likelihood of a phenomenon occurring. It is used to measure relationships between humans and complex variables. It is a means of understanding and visualizing different probability models, and it is a theoretical method to prove or disprove the null hypothesis. The null hypothesis, in short, is that a phenomenon will not exist somewhere. And so if you are able to statistically have significant values, then it disproves the null hypothesis by basically saying that this phenomena does indeed occur in this location. So this is what I used, the study area. I created a set of control points to act as the null hypothesis, or the zero group in my study. And this is one of the tables that was produced from the regression. 35% of the study group, or the control group was correctly identified. 81% of the humane borders recovered bodies were correctly identified. So I feel like that's a fairly high number. The overall percentage is 59.5. The threshold for significance is 0.5. So it could be higher, but it's also above the cut point. So here we see my independent variables, which I referred to earlier as terrain layers. The key categories here are the B column. This refers to the intercept, or the intercept value. The Wald score is a measure of statistical significance. Lower numbers equal greater significance. And then finally, the significance score over here, where you could see that only 2 of the 8 terrain layers returned a significant value. Finally, this is my binary regression model. And if you notice, it looks very similar to the shelter and the roughness, I believe. Oops. Shelter and the roughness category. So the DEM, or the image itself, looks similar. So it would make sense, using the raster calculator, that it would quantify areas that have higher values in that field to where it would be most dangerous in terms of the terrain model. And as you can see visually, and also as I've looked at I've ran an analysis of where the points were located in ArcGIS, that a lot of the people who were recovered were not found in the most dangerous areas. There are a number of reasons for this, which I will go into if I have time at the end. but the main one being that a lot of times bodies who are recovered have been moved either by friends, loved ones, or people who are out there looking to recover remains. But theoretically, the areas up here would be the most dangerous because they're the highest in elevation and they're the rockiest and they have the most exposure. But it just doesn't happen to correspond with the actual data. So I want to close with this image here. This is from Jason DeLeon's Hostility 94 installation. He is a professor out of the University of Los Angeles, anthropologist and amazing researcher. And I thought I've been thinking a lot about the idea of a hostility index and where it came from. And I believe this image, while more in the realms of humanities and art, was very informative for how I came to this idea. Because fundamentally, what I am trying to do is to not only raise awareness about this issue, but to increase empathy on the subject and remind people that it is still an ongoing problem. These are my image credits, and that's all I have for my presentation. Thank you.